Hi, everyone. I am Esther Alter, and this is a talk, What is MonoBehaviour.Update? A little bit about myself. I am a research simulation software engineer, which is a mouthful, but what all that means is that I use machine learning tech, typically in Python, and video game tech, Unity, to create virtual environments that scientists can use to do machine learning experiments. I am also an independent game designer. I'm probably best known for my works Neocolonialism and No Pineapple Left Behind. I am based in Massachusetts, Salem, Massachusetts, in the Boston area. So for the purposes of this talk, I'm going to assume that you either kind of know how to use Unity, or you tried to use it once, got confused, and gave up. But you have a basic sense of what the interface looks like, and like what a script is. Like at some point, you tried to make a script, attach it to a game object, and whether or not you understood what you were doing, I assume that you've attempted this at some point. I'm also going to assume that you more or less know what classes and methods or functions are in the context of computer programming. In case you don't, very roughly, classes are nouns, methods and functions are verbs. So in Unity C#, a class could be like an orc or a dog or an airplane or something, and everything is grouped into these nouns, and then each of those will have some methods like move or fly or whatever, and that's how the code has to be organized. When you create a new script in Unity, it looks like this. So everyone gets this as their first script. And we can ignore the things that are in gray. That stuff doesn't matter for the purposes of this talk. What matters is this, which it says that this is a class and it's called new behavior script. If I had named the file something else than the default name, it would be called that. So if I named the file orc, it would be called orc. New behavior script is a kind or a subclass of MonoBehaviour. And it has this method here called update. And update, as the code comment tells us, is called once per frame. But what is MonoBehaviour.Update? What we know so far is that it is a method in the MonoBehaviour class in Unity 3D, and it gets called once per frame. And if you read through Unity's API documentation, you'll learn a lot more about what it is and perhaps what it does. But the documentation won't tell you why it's structured that way and why it does what it does. The reason is to simplify the organization of the main game loop. But in my experience, in my personal experience, and in my experience talking to people new to Unity and to students, this is actually quite unintuitive if you don't know what you're looking at. It's not clear to many people what update is doing to save them time, why it exists at all. And a lot of people confront this and other strange Unity idioms, and they get confused and they give up. And if they don't get confused and give up, they might go on to create huge bugs that are difficult to understand because they don't understand the implications of update and what it's trying to do, and they end up fighting against it constantly. So that's a problem, not just because people give up faster, than they give up very quickly, but the problem is that many people will start doing game design with Unity. A lot of academic courses, as well as online tutorials, kind of be like, well, start with Unity and lead you through it. And if you start with Unity, you might not understand what things like MonoBehaviour.Update is doing. without some background information outside of Unity. So this talk is going to be about what the main game loop is. That's the problem that MonoBehaviour.Update is trying to solve. I'm going to tell you about how it does solve some of those problems and how it also creates new and exciting problems for you instead. So most games need to have a main game loop. And I say most because you can have some like adventure games, like twine games, that don't have to have this structure, where instead of a loop, you're falling through a tree of choices you're making over time. But aside from those, most games have to be structured around this loop. And this makes them distinct from a lot of software, especially web development. And the loop looks like this. While the game is running, you first check if any events have happened. And an event can be really anything. The most obvious things are input, like a button press or a joystick or a mouse click. But they could also be events within the software itself, such as an attack, a message from the internet. It doesn't matter what an event is ontologically. The important thing is that it's sort of an instantaneous happening, that this happened right now. The second step is, given the state of the game, given the result of the events, you update the state of the game. So if you received a mouse click, then maybe that means new move orders. If there was an attack event, something loses HP, and so on and so forth. And then from there, you update the graphics. So if something lost HP, you might have to play a certain animation. And then you loop to the top of the loop, go to the top of the loop again. And these 4 steps are called a frame. And what a frame is, especially in Unity, is actually much more complicated than this. But this is sort of the bare essence of it, that you receive events, you update the state, and then you go back to the top. And you repeat this loop until the game ends. In Unity 3D, what's actually handling the game loop can be thought of as implicit, and I'll explain exactly what that means pretty soon. But in other game engines, it's explicit, and by that I mean that you have to write the entirety of the main game loop and structure it correctly. So by way of counterexample, I'm going to introduce you all to Python and PyGame. PyGame is a very simple game engine. And it is difficult to use because it is so simple. So PyGame is like just the bare essentials for 2D games. So PyGame will give you events, so it can listen for mouse input, and it can draw like rectangles, but it doesn't have a built-in notion of a button, for example. If you want to code a button, you'd have to register the mouse event and define a rectangle on the screen and say if the mouse was within this rectangle, then the button was clicked. So it doesn't do any of that basic stuff for you. It does like just the raw ingredients. And that can make it hard to use. It's very hard for you to use for me, but it is very useful for learning why certain game design problems and game engineering problems, such as the main game loop, how they work and why they're difficult. I mentioned at the start of this talk that I'm going to assume you know a little bit of Unity and a little bit of what's called object-oriented programming. I don't assume you know Unity and Python, because that's often a weird combo. So very briefly, C# is organized always into classes, and classes have methods. All of the code has to be in classes. That's not the case in Python. In Python, methods are called functions because reasons, that's what they are. And functions don't have to be in classes. Sometimes they are, and sometimes they aren't. So the example I'm going to show you uses functions outside of classes. It's the bottom line is that the core of how this thing works is basically the same as in C#, but it's organized differently. So this is a tiny example of a PyGame game. And if I ran this, all it would do is create a blue screen. Not of death, just a tiny little blue screen. I just got a little ping. Sorry. This is the main function, and it's going to be handling our entire game. Again, this is something you can't quite do in C#, but this is a function that's just like floating on its own. The stuff that's in the pink bracket is the main game loop. And this tiny game is going to loop until someone presses the escape key, at which point it quits. So here's step one. Get all the events in this frame. For event in PyGame.Event.Get. And how that works, don't worry about it. This is the thing that PyGame is going to do for you. It's going to register keyboard events and mouse events and some other events. And then we have a conditional here that says if the event is key down, which means that someone pressed a key. And if that key was the escape key, running equals false. And if running equals false, this loop is over. And then we just have some instructions down here to flip the screen. And that just means update the graphics. And so we have get the events, and do something with the events, and then continue to update the screen. And then we loop back to the top, and that is our main game loop. So somewhat more complicated example. Oh, sorry. Here's the thing about writing these game loops. This is a very simple example. The good part about writing your own game loop is that you have complete control about what actually happens on a frame. So if you have lots and lots of entities or lots of complicated graphical states and for rules reasons or performance reasons you don't want to update some of them, you have total control over that. If you're writing your own main game loop, you have very precise control. The downside is that this will get very complex very quickly. And you will be responsible for not making mistakes, and it'll be very easy to make mistakes. So this is the example I had mentioned when I forgot about that previous slide. And this is my #1 hit game, Orc Mover 5000. You don't need to squint your eyes to look at the code. The important thing is that this is all of the code to make this example. It's not that long. And what it does is that if I click the screen, it shows a little red circle, and the orc moves to the circle. This is a prototype of it called Orc Not Mover, and what it does is it puts the orc on the screen, but you can't move it. So we see in the code that it creates the screen, a couple lines down it creates the orc, and then it puts the orc on the screen. The reason you can't move this is because there isn't a main game loop, and it's not registering input, and it's not iterating through frames. If I wanted to make the orc move, I would include some code like this. While running means that we start the main game loop, and we have a different event than last time. The previous example I had was a key down event to register the escape key. Now we have an event that registered mouse down events. And so we get the mouse position and we set that as the orc's destination. And then having received that, every single frame, the orc is going to move towards the destination. Don't worry about the math in the middle of this, about how it's moving. That's not relevant to this talk. The important thing is that every single frame, the orc is moving to a destination until it arrives. And then at the bottom of all this, we always update the graphics. But in the example I showed you, I also had this little red circle, which I guess in like a game like StarCraft or whatever would be like a flag that you drop so that your units can start moving towards it. And the circle works in a very similar way. It listens for a mouse down event, and if it gets the mouse down event, it draws a circle, and then over time it shrinks the circle. And if the circle is all the way shrunk down, it goes away. This is also handled pretty much the same way. It's listening to the same event. But if I try to put them together, the first time I tried this, I had a problem. And the problem is that the red circle appears first and then the orc moves, which is not really what I want, especially if this was like sort of a fast-paced action game. What I want is this, where when I click, I get the circle and the orc. So to define the issue more stringently, the problem is that these are sequential actions, that First, the circle is drawn, shrunk, that whole animation occurs, and then the orc animation occurs. These are sequential actions having received the same event. What I want to happen is I want to check to see if we should draw the circle, check to see if we should move the orc, and then draw the circle and move the orc accordingly, depending on what the state is. So the best way to handle this case is to have two different states. So the orc can be restructured so that it has a state. It's either moving or not moving. And if it's moving, it's implied that it has a destination to go to. And when it reaches that destination, it's no longer moving. The circle similarly has two states. It either exists or it doesn't exist. And if it exists, it's implicitly shrinking in size over time. And when it gets to 0 size, it no longer exists. So we're going to be able to do that by restructuring the code for the orc and the circle into what are called state machines. And that's a more technical word than it ends up being. It just means that they are going to keep track of their own states. So the orc's going to track whether it should be moving versus not moving, and the circle is going to track whether it exists or doesn't exist. And instead of deciding which animations to play in what order, we're just going to give the state machines an announcement. We're going to say there was a mouse click event and the mouse clicked at this position, and they're going to decide what to do with that information. Each state machine, importantly, has a function called update, and that update function is going to get called by main every frame. So to restructure the code into state machines, it would look like this. Now the circle and the orc are state machines. Don't worry about what's being hidden here. So those are two different classes, and I'm not going to show you what's within the class code. It's not relevant to this talk. The important thing is that everything's sort of tucked away now. And this is the main game loop. Same as before, more or less. We listen for a mouse event. But now each state machine registers the mouse down event. So we have circle.onMouseDown and orc.onMouseDown. And then each state machine calls an update function every single frame, given what is received. So maybe circle.onMouseDown says, OK, start drawing a circle here. Orc.onMouseDown sets the destination. Circle.update will start shrinking at every single frame, and orc.update will, I guess, move it to the destination. So now we've got everything in state machines, and we have everything in concurrent states so that we can track everything at once. Actually, I just want to point out, this isn't true concurrency. You can see that circle.update happens right before orc.update. So actually, they're sequential. So circle always goes before orc. But this is going to occur so fast, the player's not going to necessarily notice. And if you want to have true concurrency on the frame, it's enormously more complicated and well beyond the scope of this talk. And usually you don't need that. So this doesn't really solve all of our issues. This solves the initial problem, which was that the circle animation was going before the orc animation. And now they're concurrent or quasi-concurrent. But this is the simplest game ever. It's like barely a game. And you still need to define all these state machines, and they have to define what they know. So the difficulty of coding everything is about the same as before. And you're still responsible for making sure this update function actually gets called on the frame. So if you have many different entities, you still have to be managing all these state machines to make sure that their states are up to date and that they're being updated when they should be. You'll hit problems like, what if two state machines interact? Like, what if there's two orcs and they need to do something together? Or what if there were like lots of state machines? Like, imagine if you had a game where instead of this one orc moving around, you've got hundreds of orcs or thousands of orcs, and you have to keep track of every single update and every single state machine. What if an orc dies? You have to take the orc out of the state machine queue or array or however you're doing this. You have to make sure that like dead orcs don't get updated or get updated in some other way. And you will have to do that manually. And if you don't do that correctly, you're going to hit a lot of bugs, and those bugs are very hard to track down once they happen. And also, your game will potentially run very slowly because you're going to be calling update on objects that don't need to be updated. This is a very difficult problem to tackle, but fortunately for you, Unity has this thing that is called MonoBehaviour.Update that's going to solve a lot of this, but not all of it for you. MonoBehaviour.Update is a method in the MonoBehaviour class that gets called once per frame. And MonoBehaviour is designed to be used as a state machine. It's packaged with the Unity engine. You get this one by default. And MonoBehaviour.Update works just like the update function I showed you in PyGame, except that it is automatically called once per frame, and you don't have to manage that. So in Unity, if I wanted to set up the same example as before, it would look like this. I would make an orc script and a circle script. Both of them are subclasses of MonoBehaviour, and they both have this update method. We're calling them methods now because we're back in C#. Before we're calling them functions. This is what an orc class could look like when I just write the whole thing. So we have this is a state machine. We have a state that's just right now a Boolean flag, moving versus not moving. On update, we have this conditional if the mouse button is down, set a destination and set moving to true. And then keep moving and do regardless of whether we get an input, assuming that we are moving. And the important thing is that update is going to get called once per frame. We don't need to manage that ourselves. So that means that Unity is going to track all of your state machine objects for you, and it's going to always remember to call update every time. And equally important, if you destroy an object or remove an object, Unity will automatically know to stop calling update when the object is gone. This is a major time saver and saves a lot of headaches. The sort of headaches you might not know you're being saved if you haven't hit this problem in other engines like PyGame. Very briefly, because I think we're a little short on time, there are actually many other update-alike methods in Unity. There's update, fixed update, late update. They're divided in such a way because of how the Unity main game loop is actually structured, and they are major time savers, but in most cases, and especially when you're just starting to make a game, you're almost always using update and none of these other ones. You'll find them in the documentation, though. As to what calls MonoBehaviour.Update, because something must be calling it, it's like magic. There's some, the Unity engine itself is closed source, and you're never going to directly interact with it. But there's something behind the curtain that is always calling this. The way it finds update is that when the program starts, it scans all your code for MonoBehaviour classes that have an update method, and it registers all of them, and then it will call them per frame. How it's scanning and how it is called reflection, and then how it actually gets called, don't worry about it. There are, however, many, many downsides to the way update is structured. The main one is that script execution is still sequential. It's sequential by class. So like maybe the orcs go first, then circles get their update method, and then elves and so on. And that's fine. But by default, the script execution order will be different between different computers. This is a wild thing in Unity that messes up a lot of people. So maybe on your machine, it goes orcs, circles, elves, etc. But on someone else's machine, it might be circles, elves, etc., orcs. And what that's going to do is that's going to create bugs that show up on your players' computers, but not yours. Because you're at some point, if your project gets complex enough, you're going to start writing code that assumes the orcs go before the elves and so on and so forth, that there is a set sequence to this. This is a major issue because that's not something that's signposted very well. It's not something an amateur game designer would understand. And it's a pretty inevitable bug once your game is complex enough. Another major downside to the way this is structured is that states can update at weird times. So let's say I have set my sequence up correctly, and now I have like a class called battle screen, and the battle screen update goes first, and then it tells all its participants, the orcs and the elves, what happened. Now, what if on update the screen gets closed, and then the orcs update, and that says keep fighting? What happens? What happens if the orcs are fighting but the battle is over? Who knows? Anything could happen at that point. It depends on how your code is structured. So now you have to have a thing where the orcs have to be aware that the screen was closed, and the screen has to be aware of the orcs, and so on. So you get what's called spaghetti code. And so everything is sort of interlocking in sort of ad hoc, sloppy ways, and it's easy to make sloppy mistakes at this point. My preference for tackling this is to actually have only one update method in the entire game. Everything subscribes to this update method, and it will manually handle execution order and update states accordingly. And that creates very tightly organized code. But the problem is that is the same kind of manual handling in the main game loop that we were just talking about. It's going to have all of the same problems as that PyGame example, only more because I'm making a more complex project. So this only works for me because I've used Unity a lot. So I know what I'm getting myself into, and I know how to organize it. It won't work for beginners, or it might, but I wouldn't expect it. My recommendation to you and for most people to understand this better is to make a tiny game in PyGame or something like it, and then get frustrated. You could finish it or not. And then make a tiny game in Unity. It could be the same game. You'll get frustrated, but in a different way. And you don't have to finish it. And that's not to say that like no pain, no gain, that like you have to like learn through suffering, because I really don't believe in that. All I'm saying with this is that a lot of people start with Unity and get really confused because they don't have this counterexample. And I think really only by comparing one to the other are you going to get an intuition for how Unity is helping you and how Unity is slowing you down. And that will begin to give you a sort of gut instinct to how to approach the problem of the main game loop that best suits your style. If you want to learn more about this or more about game design in general, Unity 3D and PyGame are both free. That's why I picked those examples. And there are tons of free tutorials for both of them, and free talks like this one. And I really encourage you to just like sit down and try something and not necessarily succeed, but the intuition in understanding how they are structured and why they are structured the way they are, that's a sort of intuition that can only be gained through experience, and that is always going to be your strongest tool in game development. Thank you. I think we have a couple minutes for questions. You can definitely do it event-driven, and I strongly prefer to do it that way. You still have to adhere to a game loop at some level. I find personally that in Unity, I'm constantly fighting Unity to make it event-driven, that Unity really, really wants everything to be per frame. PyGame really assumes that it is event-driven and that everything is not per frame. And that's because PyGame is like extremely slow. So it assumes that if you don't need to do something, you're not doing it.